Hello everyone. Today we're going to solve another problem in motion of a particle. And this problem includes a satellite. Well, we're going to mostly do the carrier, the rocket that carries the satellite, but it's a satellite. So let's see what is our learning objective for today. We'll solve a problem and we'll apply the vertical motion equation that we have learned to solve variable acceleration problem. This is a problem that I saw and found most of the students have issues with to understand, and then the problem will have the rocket or the satellite launched. It will have some acceleration up to some height, and then the engine will fail and it will include some free fall from that point to the ground. So we'll have fun solving this problem. Let's see what is the problem. So the problem says that a satellite is fired vertically upward with an initial velocity of 100 meter per second. So what is our knowns are initial velocity u is 100 meter per second. The carrier rocket, so the rocket which is carrying the satellite, is accelerated from the beginning at 5 meter per second square. So acceleration is 5 meter per second square until it reaches an altitude of 1000 meter. So if it's the ground, it reaches until it reaches 1000 meter. The acceleration was 5 meter per second square. After that, engine fails. So right after this point, from here to the maximum height, the acceleration would be z, because it's a free fall, which is 9.81 meter per second square. So though the engine fails at this point, the rocket will still go up because it will have some final velocity from here to this point. So until the vy, the velocity becomes 0, it will go upward. And it will reach a maximum height, and then it will start to fall back to the ground with free falling. So these are things are given. So what are the unknowns? It asks us to find the time of the flight. So the time of the flight from the start point here until it hit to the ground. So the whole flight with the acceleration and with gravitational acceleration and free fall, everything. So what is the time? And that's our A. And then we have a B, which is the maximum altitude. So the maximum height from ground to the top, so h max. And C, velocity just before striking the ground. So velocity just before striking the ground here, so v just before striking the ground. So these are the unknowns. So let's try to solve the problem. So when we want to find the solution, what we would like to solve first is the time for A. So the time required to travel the rocket from 0 point to height 1000 meter, because the time it needs to be at 1000 meter is not the same because the acceleration is changed from here to this position. So we'll consider from up to the 1,000 meter distance first. So if we apply the equation height h, we can call 1,000 meter as height h1. So height h1 equals to ut plus half a t squared. So remember, we put plus because it is an acceleration towards the upward velocity, and this is the acceleration including against the gravity, so we don't have to consider gravity in this equation. This acceleration, which is 5 meters per second square, includes the total acceleration of the satellite. So if we now put the values, h1, which is 1,000 meter, so final 1,000, initial was 0, so total 1,000 meter. U, initial velocity was 100 for us, we don't know what t is, plus half acceleration, which is 5, and t square. So now it's a equation of quadratic equation, ax squared plus bx plus bx plus c equals to 0. So if we solve that, we can get time t equals to 8.28 seconds. So this is the time t, we can call it t1. So time required to cover the first 1,000 meter, or we can say t1000, so that we can know that it was the time required from ground to reach at 1,000 meter. So we know that we had the initial velocity of 100 meter here at the ground. Due to acceleration, we will have a different velocity when we reach at 1,000 meter here. So what is the final velocity at 1,000 meter? Well, that's simple. We can use the equation v equals to u plus at. Again, it's a plus because it's a acceleration towards the initial velocity direction. So if we plug the value 100 plus a equals to 5 and multiplied by time, what time that we just found, the time required to reach 1,000 feet, so 8.28. If we solve this, we'll get the velocity, final velocity at 1,000 feet, which is 141.42 meter per second. So this is the final velocity at 1,000 meter. So we got the time at 1,000 meter, and this one we'll use these two to solve our next unknowns. So we know this height h1, and if we can find out the height or the distance from here to here, if we call it h2, if we sum up h1 and h2, we can get the total height, which is h or h max. So to find this h2, we have to start another equation. Let's move to next page. So we know when we'll be at maximum height, the velocity and the final velocity would be 0. Final velocity in y direction would be 0. So if we apply that concept to find h2, So final velocity square equals to initial velocity square minus twice z h2. So now consider why we are using z, because there is no other acceleration acting. It's a free fall, so only the acceleration is acting is the gravitational pull, and it is against the direction of the final velocity, so it's negative, and h2 is the height we're looking for, and v the final velocity at maximum height, which would be 0. So if we solve if we plug the value, okay, another thing, what would be the value of u this time, the initial velocity? Well, we had the final velocity for 1,000 feet travel as a v, this one. So this value is the initial velocity from here to the maximum height. So our u, we know it would be 141.42 whole square minus twice g, we know 9.81 h2. So now if it's 0 on that side, if we solve for h2 now, we can get 1019.34 meter. So this is h2, and we know h1 is the 1,000 feet, so the maximum height we can find out is the h1 plus h2, which one is 1,000 plus 1,019.34 meter, which will lead us to 1,019.34 2019.34 meter. So this will be our maximum height. This we solved one of the required unknowns. Now we're gonna move to second part of it. How much time it required to travel so how much time it required to travel from this height, 1,000 feet, to all the way back down to the ground. To find that, we'll use again the equation of so this time we can call it time for free fall. So after the engine failed, time for free fall. So delta s equals to ut, the initial velocity, time multiplied by time, minus half, again the gravitational pull is against the initial velocity, gt square. So u, we know the initial velocity at 1,000 meter, because that's the free fall start point, 141.42. We know z, we know, so what will be the delta s? So delta s is the final change in displacement. The final displacement is the ground, which is 0, minus the initial point. Now we are at 1,000 feet height, so that will be the delta s. So if we simplify, we get negative 1,000 equals to 141.42. That is our initial velocity at 1,000 feet multiplied by time, that's what we're looking for, and half into 9.81 in t square. So again, it's another quadratic equation. If we solve for t, we can get the value t equals to 34.7. One thing I wanted to, and it's it's the time for free fall, or we can write t free fall. So one thing, since it's a quadratic equation, you'll see that you will get two answers, one positive, one negative. So you know that time cannot be negative, so time cannot be negative. We have to take the positive value, so it's simple. So which answer you choose when you had two solution. So this is the time in second for the free fall scenario. So we had calculated the time to reach up to 1,000 feet. So from ground here to 1,000 feet, that is 8.28 seconds. And now we just solved the from 1,000 feet to the ground, which is 34.7 seconds. So the total time, the travel time or flight time, would be t1000 plus t free fall, which is let me see, 8.28 plus 34.7, which gives us 42.98, which is approximately 43 seconds. So this is the this is our answer for the flight time. The question of the time of the flight before striking the ground. So this is the answer for the first A, and this is the maximum altitude, which is the answer of question B, and this is A. Now we are left with the last question, which is the velocity just before striking the ground. So the third part, which is C. So now this part is a little simple. We know the equation v square equals to initial velocity square minus twice g delta s. So we're taking negative z, meaning we're considering only the free fall part. So at the ground we're looking for v. So v we don't know. What is u? It is started from 1,000 feet to the ground, going up and downward to the ground. So we get the velocity 141.42 whole square minus twice into 9.81 delta s. What would be the delta s? So it started at 1,000, and the end point, so end point is 0 to the ground, and it started at 1,000 feet, so that's delta s. So again, it's all numerical value on the right side, so we can find v if I take square root of the thing that is here, and we can get the final velocity, which is 199 meter per second. So we got the final velocity. That was our the question part C. So we have solved all the problem. So in next in next video we'll start a new chapter of the book. Well, till then, thank you.